Project 13-9 covers basic database. Now in business, pretty much the database is the most important part of the company. It stores all the information from customers to billing to inventory to employee payroll. So having a rudimentary knowledge of a database is very important, especially with security. Knowing some of the basic syntax of SQL statements will help you develop or pick products that are secure, so somebody cannot go around security by typing in odd commands in a field on your website and send it to your database server and break it. So we're going to do this on Ubuntu. Make sure actually it doesn't matter on the network really. On this one it probably should be at bridged or NAT, and we'll go ahead and click start. While the system is booting, look up a little page here, MySQL versus PostgreSQL. And these two are open source database that are common in the Linux and Unix world, even on Windows. The two versions have kind of merged feature-wise with each other. Postgres used to be known as the more advanced one, a little bit slower, but had many of the same features that Oracle database did. Now they're staying with the latest versions. They both have about equal set of backend options. So both of them are really advanced and free databases. Now with Ubuntu loaded, we'll log in as root and pass 1234. Most databases require a user to run the database. So database is normally kind of like an application platform. It stores data and you write applications to interact with the database. And because of that, it has security, and you have to have user accounts that can access the data. So we're going to create or set a password for the Postgres account that's already in the system. In an Oracle database, they use the user account Oracle. So here the user account's created. We'll switch over to that user. And very similar to an Oracle situation, you'd want to switch over to the Oracle user for managing the database, so you have full administrative access to the database. The database is normally a collection of a few large files that contain thousands of tables, or you could look at them as Excel spreadsheets that are linked together. We're going to create a database and name it sales. And then we're going to use the utility to connect to the database for issuing commands. We can do a \L to list what is in the database. We see sales. We also see Postgres, which contains information about the program itself. And then you have a couple of templates down there that are used whenever you create a new database. It'll create it based off of the template. Now we need to hit Q so we can get our prompt back. We'll issue a SQL statement. It's not really case sensitive, or normally not. We have create table. Normally SQL commands aren't uppercase. And then the name of a item is typically lowercase. So we'll type in customer. So that's going to be a new kind of like Excel spreadsheet, and then we're going to specify the columns that will be in the spreadsheet. Name, and it can accept up to 20 characters. So this prevents you from typing in an encyclopedia. If anybody remembers what encyclopedias are, a young crowd may not, but an entire wiki into one field. You only have a 20 character name. The address field will allow for 40 characters, and the balance field will allow for 10 characters. And don't forget the extra closing parentheses. That closes the parentheses that was in front of name at the very beginning. And then a semicolon is always the end of the execution. Sometimes you have to write several lines of code before you want to execute all of it at once. So we hit enter. It should say tables created. /D is going to show us the customer table. /D customer will show us the columns that are in the customer table. So you have the name column, address column, and balance column, and shows you how many characters each can be in those columns. Now you do the insert into the table name, and then the keyword values, and we're going to place inside of there, we'll have to use single quotation mark, Lily Bo Peep, in single quote. That means that read all of that as text. And then again, another single quote to open up. We use the comma there to separate the two text fields. 123 Rutherford Lane. In single quote. So this becomes important when you take Introduction to Security, is noticing that everything that gets put into a database has to be surrounded by single quotation marks. When you're outside the single quotation marks, it is looking for SQL commands, table names, and stuff like that. So I'll show you that when you take a SQL class, probably with me. An intro to security. You'll see how hackers can use this knowledge, the syntax of putting in stuff to break or hack into your database. So we've got several others to put in there. I'm just going to use my up arrow key and make sure my numlock is on, and then modify the couple of values here. Instead of retyping all the single quotes and retyping the whole line, I'll just change the due date or the due amount. The address and the name, making sure you don't mess up the single quotation marks or commas. So do that for the other two, step 12 and 13. Okay, I finished entering in my entries. Now this does not have a primary key field or multiple tables and normalization between tables. Those are several semesters of study to get into detail on that. There's PhDs and stuff that do documents on normalizing a database. You can go Google what normalizing a database is if you want to. That is major steps there. So now this is just real simple, plain table, some data in it. Now we'll use a select statement. It's a very common SQL statement to get stuff out of the database. Select. You can list the column names if you don't want to view them all. We'll put a star since we only have 3 columns in our table. And then specify from customer. So there are 4 rows and the information that we've put in them. I can rerun the command, select star from customer, but this time do a SQL statement, order by. We'll order by the balance column. And we're going to order it in descending order. So here it shows the highest to lowest. Another type of select statement, instead of order by, we can look for just one particular entry. Most databases will have thousands to millions of entries. So we're looking for where name is equal to this person. So it'll return just that one person. If you've ever searched Google, this is basically what happens with Google. When you type in the search field, it has a select star from whatever, the internet, and where search equals whatever you've typed in search. So you can kind of think of that as what's happening behind when you search things on Google. And then it returns everything that has those words in it. Of course, it doesn't have where. Normally probably it'd have a different command. Command being like, L-I-K-E, in place of where. Now we're going to create a user. We're going to name it Bob. Users created would be used with, say, an application that you'd write, maybe a graphical front end to access this database. And you'd use a user that had access to do certain things with just this one database and not other databases that Postgres would be running. So this is running sales database. You could also have an HR database, inventory database, each of them kept separate with different user accounts. So we create a user Bob with password super secret. And then we're going to grant all privileges on the customer table. So these individual user accounts don't have to have access to the, say, every database. It could also just be restricted to a particular table to modify. So all privileges granted on the customer table to Bob. So like I said, if we were writing a program, we could use Bob and he could edit anything in the customer table. So do /Q, I believe it was, to quit, and then exit to exit out of the system. And that ends this video. But I'd go ahead and look up standard SQL commands and just kind of get an idea of the syntax. And when you take other classes, just having an idea in your background of how SQL works will help you out.